So the next lesson we're moving on to is lesson 2.7. Like usual, read the problem of the day and answer both parts A and B. When you're ready, you can resume the video. Now, today we're looking at lesson 2.7, use absolute value functions. And before we start to fill out the table here, I want to pull something up. As I said, we're going to take a look at a GeoGebra app with an absolute value. So let's take a look at this here for a second. In the corner it has what the function is and three terms A, H, and K. All right. A little slider tool. So we could sort of talk about absolute value. First of all, absolute value graphs are V-graphs. All right. And right now we notice H is 0 and K is 0, right? So here's 0, 0 right here. All right, well, let's take a look. If I take, we're going to go with H first. If I take the H slider and I move it, let's see what happens. Okay, so if I move it to the right, as my numbers increase, it moves to the right. As it decreases, it moves to the left, right? So look here. So H is -5. Here's my number -5 here, right? But look what happens here. Do you see how it's H equals -5? But look what it is inside the absolute value bars. It's a +5. All right, so what happens is whatever number is inside the absolute value bars, that's what, the x, and it's sort of the opposite sign. It starts with a +5, but really on the number line, and the h is really, as well as the h, is the -5. And if you notice, that's what? Our x-axis. So we're going to call h in this lesson our x. All right, so let's move it back to 0 there. Okay, so let's see what happens with the k. When I move it up, it goes up. When I move it, like the numbers increase, it goes up. When it decreases, it goes down, right? So k, if you look, let's keep that -5. K equals -5. Well, now the -5 number's off to the right. This is my y coordinate, or my k. So h is x, k is y. The k is the number off to the end, exactly the same, -5, -5, it's -5 here. The h or the x switched signs. Now A, let's see what happens to A. All right, A makes it either very, very, very narrow, the bigger we get, the smaller and smaller we get. And look, under, here's 1, right? Under 1, it gets really, really, really wide until we almost hit, until we have nothing, right? So A I think of as my slope. It's the number that's in front of the absolute value bars. So in order to determine anything about absolute value graphs, we have an A, H, and K. A is the slope, H is the x coordinate, K is the y coordinate. All right, so let's start to fill out the notes here now that we saw the slider. Absolute value function, f of x equals absolute value of x. Vertex, the highest or lowest point on the graph of an absolute value function. And we saw that the vertex is like your x comma y or your h comma k. General form, y equals a, absolute value x minus h plus k. So here's my a, here's my h, here's my k. So let's type in what each of the jobs are that you could fill out in your chart. All right. Job of A is the slope. All right. And we saw that it got either wider or narrower, and we'll talk about that in the next slide. H is my x coordinate. All right. And then my k is my y coordinate. Now you might be asking, why do we not call it x and y? Well, in math, we want to differentiate between the parts here. And really, what do you have? You have an x here and a y here. So we're going to call it something different. All right. So to talk about the A, you saw that in the slider graph. A, when the absolute value of your A, your slope's the number in front. If you take the absolute value of it, because it doesn't matter if it's positive or negative. If you take the absolute value of it and it's greater than 1, you're going to stretch it. The graph is vertically stretched or elongated, as in it's going to be narrower. And let's look at that GeoGebra app again. Okay. So A is 1 here. If it's greater than 1, look what happens. It's getting narrower and narrower. They call it stretching it because it's like you took the two parts on the top and bottom, stretched it out. So it's getting narrower and narrower. Now, the flip side, let's jump to -1 here. Look, it's getting narrower and narrower the bigger the number. It doesn't matter that it's negative. All negative means is it opens down, it flips, but it's still getting narrower. So if we go back to what I said here, the graph is narrower than the graph of y equals absolute value of x. So that would be like the 1 there. So if the number in front is greater than 1, it's narrower. But what if it's less than 1? The graph is vertically shrunk or compressed. The graph of y equals a absolute value x is wider than the graph of the original. Okay, so let's go to the original here. I'm going to switch back. The original standard one that uses the slope is a, or excuse me, the slope is 1 or a is 1. So this is the standard one. What if it's less than 1? So it's between 0 and 1, right? So less than 1, look what happens. Say it's getting wider, right? So that's what they're talking about, it's wider. And once again, they say absolute value because look, here's -0.2, -0.3. It's still wider than this. So maybe I'll go backwards. So here's -1. Just flip down, wider, 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 wider. And then we get to 0. All right? So the negative just means it opens down in front of the A. All right, so we're going to describe each graph, and there's a couple parts that I want to talk about. If you look at actually the homework, I don't have the directions here, but the homework keeps it the same exact way that matches up. So A for A, I know it sounds a little odd. We're going to say, what is our AH and K? All right, so my A is the number in front of the absolute value bars, and if you notice, there's no number, so it's just 1. My H is going to be 3. My K is going to equal 4. Now you might be wondering, well, how come it's 3? What I like to think of when I do the x is I set it equal to 0. Actually, give me 1 second here. I want to fix that. So that's how I got that. And x, remember, we really want to call it h. All right. So you set the absolute value bar is equal to 0. But for the k, it's the number off to the right. You don't have to worry about it. It's the same exact sign. All right. And then the 1 was from here. We didn't have the 1. All right. Now, for the next part. Okay. So now for the next part with this, we also want to say, does it open up or down? Well, A is what? Positive 1, so it opens up. So that's what we're going to say for A. Move this as well. All right, part B. B, we want to talk about the width of the graph. And if you notice, it's 1. So, and like I said, you might want to look at your assignment that matches up to this. But the next part is we're going to talk about, is the width the same as y equals absolute value of x? Is it narrower or is it wider? So do you guys see this here? It says this one, if it's greater than 1, it's narrower. If it's less than 1, it's wider. All right, well, A equals 1, right? So it's the same width as y equals absolute value of x. Because it's just a what, 1. So it looks like this one. There would be a 1 here. All right, so C. C, what's the vertex? Vertex is x comma y or h comma k. That's my vertex. Oops. And what's my slope? Slope is a, and it equals 1. So there is my list of problems here. So let's do B, same thing. then maybe, you might want to pause the video and try it yourself. So A, I want to know what my A, H, and K are. A equals 2, H equals -7. Remember, we're setting this equal to 0. K equals -2. A is +2, so it opens up. Okay. Once again, remember, to get the H, we set it equal to 0. Okay, so just so you know, that's how we get that. All right, so B. B, we want to know the width. My A is 2. 2 matches up. Think about what chart it matches up with. Absolute value of 2 is 2. 2 is greater than 1. So 2 fits into this one on the left. So I'm going to say, what do we use the word? Narrower than y equals absolute value of x. Okay, C. C, we want our vertex. It's against h comma k, or -7 comma -2. And D, slope. Slope is your A. And there's our answer. Let me give myself a little room here. Okay. So let's try C. Once again, same thing. A equals 1, H equals -7, K equals -2. My A is 1, so it's same width as y equals absolute value of x. Oh, might help if I put B here. C, my vertex, is -7, -2, and D, my slope, A equals 1. Let's try the last one here. A is -1. Remember, it's -1 because there's no number in front except the sign. Now be careful with H. For H for this one, we have to set up, and I'll do it over here, 2x plus 4 equals 0. So you actually get -2, so be careful with this one. -2. And then this one opens down. Let's move this over. Actually, mentioning that, I forgot this one. This one opens up. All right. And then B. If -1, it's the same width as y equals absolute value of x. All right. C, vertex is -2, 1. And D, slope, equals -1. All right, so we're just doing a lot of identifying here for each of the parts. Now, how else will we? So for the last part here of today's lesson, example 2, write an equation for each graph. So now you see the actual absolute value graph. What we have to determine are two things, right? Well, three parts actually. So like A, H, K, right? And we'll do that by slope and vertex. We did that a lot in the previous page. So I'll do the vertex first. And if we see here, what is it? It's 0, -4. My slope A equals, and how we determine it, and I'll actually look at use the pointer here. So here's at the start. We go up 1, right 1. Up 1, right 1. Up 1, right 1 should be the slope 1/1 or just 1. So now how do we write that? All right, so let's take a look. So I have this information. We know our formula is y equals A, absolute value, x minus h plus k. So here's my formula. Let's plug in h, k, and a. So y equals 1, x minus 0, plus k, or plus the -4, so it's -4. And you can leave that as the answer. You could simplify it as, we don't really need the 1, right? The 1's understood. Either answer would be sufficient here. I'd accept either one. All right, so try the next one. Find your vertex, find your slope. You might want to pause the video to try it yourself first. So my vertex is 1, -3. My slope, up 1, right 1, up 1, right 1. Again. Like I said, it's like you're starting, okay, so start here, up 1, right 1 to here, right? So you're counting slope again, on the right-hand side, I should say. So if I plug this in my formula, I get the following. And you can leave it like that, or you could just say this. You could get rid of the 1 in front because it's understood. And either one would be your final answer. All right, that's it for today's lesson. Homework, work on the following problems. And remember how I said in example 1, I didn't say the directions. Hopefully that didn't confuse you too much. Here they are, they are in the homework pack, but they're also here for 2, where it says for the function. All right, and that's it for today.